Hello everyone. In today's tutorial, we're going to study standard deviation, the variance, and the range. So let's start with the standard deviation. Abbreviated as SD. Standard deviation is a measurement of how the data spread around the mean, and we can have high or low standard deviation. High SD value means that the data are more spread out, while low SD value indicates that the data are clustered around the mean and they're not widely spread. To better understand this, let's use something called the blot distribution. In the blot distribution, we can have normal or skewed. In this example, we're going to use the normal one. In the normal distribution, we have our mean located in the middle with a value of 0, so the mean equals 0. And each degree of deviation from the mean is indicated by one standard deviation. So we can have one standard deviation value, two standard deviation, 3, and more. So if you notice, the further we move away from the mean, the higher the SD value is. And that means these data are deviating from the mean more, and thus we consider them less reliable because we want our data to be mainly around the average value, around the mean. So if you have data that are far from the mean with high SD, these data are considered not highly reliable. Let's go back to the standard deviation. We have two formulas for SD, one for the population, which is indicated by the letter sigma. So sigma equals the sum of all data set point minus the population mean, all square, divided by the size of the population, which is n, all square root. And we have a formula for a sample. So the sample, which is S, remember, sample S equals the sum of all data set point minus the sample mean, all square, divided by the size of the population minus 1. So n minus 1, and all square root. If you can see, the differences between these two formula is that we use different means. So we use a mean of population here, while we use a sample mean. And here we use the whole size of population. In a sample, we say that we use the size of the population minus 1. But let's first understand, what do we mean by a population in a sample? If we say that we have, like for example, this circle here, and we have a smaller circle within it, the entire circle represents a population. So we're getting sigma for it, while a smaller part of it, this specific group, is the sample. For example, if we consider the university student at Michigan, our population, so our sample can be the medical school student at Michigan. So they are more concentrated, more specific part of data from the entire group. Now let's take an example to see how we can calculate the standard deviation. See this example here. Consider the following sample data, and we are given these numbers. So we have a sample here. The first step to get the standard deviation of the sample is to calculate the mean of the sample. And we know that the mean is the sum of all data divided by the number of these data. So we're going to add these numbers here, 57 plus 58 plus 59, and so on. And we're going to divide them by their number. So we have 1, 2, 3, 4, 5, 6, 7, 7 numbers. Get your calculator. It gives you 60. So we calculated the sample mean, which is 60. What I recommend you next to do is to make a table. So let's make a table together. The table should consist of 3 columns, in which the first column is going to be the data we have, so X. The second column is going to be every data point minus the mean of the sample, while the third column is going to be data minus the mean all square, which is basically the second column square. So let's do it together. First, we're going to set the numbers we have, so 57, or 58, 59, 60, 61, 62, and 63. In the second column, what we're going to do is, let's do the first one here. So X minus the mean. First number is 57. So 57 minus 60, which is the mean, gives you minus a 3. And yes, don't panic if you see minus, that's correct. So minus a 3. And the rest we're going to do them as we did. So 58 minus 60 is minus 2, 59 minus 60 minus 1, 60 minus 60, 0, 61 minus 60 is plus 1, 62 minus 60 is 2, and 63 minus 60 is 3. After you get all these values, what you want to do is to get the sum of them. So you want to add them all together. Add the numbers in the second column. So it gives you 0. And you have to have 0 as the sum of the second column here. If you didn't get 0, that means you did something wrong in your calculation. So you can go back and check your calculation. Maybe you did something wrong in the mean or here in this column. After you get 0, you can move to this third column. As we said, the third column is we take each number from the second column and we square it. So minus is 3 squared gives you 9. Minus 2 squared is 4. Minus 1 squared is 1. 0 squared is 0, sorry. 1 squared is 1. And 2 squared is 4. 3 squared is 9. And you need to get the sum of them as well. So add these numbers. 9 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9. And gives you 28. Let's put our formula back. So not sigma, we're calculating a sample, so we're going to say S equals the sum of all data set point minus the mean of the sample all squared over n minus 1 and all square root. So if you see this part over here is actually the 28 that we just calculated, because what we did in the 28 is that we took the sum of the third column, so the sum of x minus the mean all square, which gives you this part. And that's why I recommend you using a table. It makes things easier on you and you can easily get this part without confusion. So let's put our numbers. So S equals the square root of 28 over n minus 1. And what is n? N is the population size, which is actually number 7 here. So how many data you have? We have 7 data, so 7 minus 1. It gives you approximately the square root of 4.67, which gives you 2.16. So our sample standard deviation is 2.16. And you can use the same steps to calculate the standard deviation of a population. The only difference is which formula you're going to use. And that's why you need to check what type of data you have in order to choose the correct formula. Now let's move on to the second part, which is the variance. The variance actually is the square of SD, of the standard deviation. And if we want to differentiate between these two without getting confusion, let's put them here. So we can say that the SD, which is the standard deviation, so SD is the square root of variance, so the square root of the variance. So let's put our formulas back. So we have sigma equals the sum of all data point minus the population mean all squared over n, and all square root. If we want to get the variance of that, the variance that we just get the square of this ST. So let's say square of sigma equals the sum of all data set point minus the population mean all square over n square root, and we get the square of that, which means that we're actually removing this square root, so we end up with this. So let's put the standard deviation of a sample. Standard deviation of a sample, which is S, equals the sum of all data minus the sample mean all square over n minus 1, and all square root. A variance of a sample is S square, which equals the sum of x over the minus the sample mean all square over n minus 1. And when you have a question and you get the standard deviation in your hand, you just easily use the square root of that number without going over the steps again and using the formula. So in our example, we had the standard deviation of a sample was 2.16. So if we want to get the S square, it equals 2.16 square, which gives you approximately 4.6 then. Now let's move on to the final part of this video, which is the range. The range is the difference between the highest and the lowest value. So it is the maximum value minus the minimum value. So let's have our example back. And these numbers will luckily have them range from the lowest to the largest, but if you have more complicated numbers and they're randomly given, what I recommend you to do is to arrange them so you can easily get the lowest and the highest numbers. So we have here 57 and 63. So our range in this example is 63 minus 57, which gives you 6. And what you need to put in your head when you calculate the range is that it should be a positive value of 0, but it can't be a negative value. And that was our video for today. Hope you find it helpful. You can find in the description box a summary of this video. Thank you for watching.